Hello and good day. My name is Dr. Jim Quigley, and I'm Technical Specialist in Cargill Animal Nutrition. I want to thank Rafael Azevedo and everyone at Alta for the invitation to speak at the Alta Cria Symposium. Many of you know I'm a great fan of the Brazilian dairy industry and really enjoy traveling to Brazil and working with my colleagues in Nutrone and throughout the dairy industry in Brazil. There's so much enthusiasm to learn and apply new ideas in dairy production in general and calf raising specifically. I've spent my career working to improve the health, growth, and nutrition of young calves, so it's super exciting to work with farmers and professionals in Brazil who are equally excited about changing production in the dairy industry. Today, I'll be discussing the idea of how to change the solids concentration in the diet of young calves. I'll introduce you to the concept of osmolality and how changing the solids content can influence pre-weaning growth, which may then impact future milk production. Again, thanks for the invitation, and I hope you find my presentation to be of value. Today, I will discuss total solids in liquid calf diets. I will review several studies that have evaluated the effects of changing solids concentration in milk on calf growth. Let's take a look. Farmers have been thinking about how much milk to feed to calves for a long time. I found this passage in a publication called The Farmer's Magazine, which was published in 1803. This farmer was thinking about feeding calves, and here is what he wrote. As the calf gains strength after calving, the quantity of milk may be increased, but too much of milk at one time is as bad as too little, until it is a month or 6 weeks old. If a calf gets cold milk, it is sure to bring on a trembling, and the cords or some other malady follows. The above has been my scheme of rearing calves, and I have never had one died of the cords if fed in this way and kept dry. And we are thinking about the same topics and discussing the same issues more than 200 years later. Feeding milk today is certainly advanced, and we have more technology like auto feeders that can automate feeding, as well as easily change the volume or the solids of the liquid fed to calves. This raises the question, as we can change the volume and concentration, what is the optimal feeding program for young calves? Several meta-analyses have indicated that as we increase pre-weaning body weight gain, we find that future milk production is increased also. Most of these indicate that calves will produce 100 to 150 kilos of milk for each 100 grams of additional average daily gain prior to weaning. Of course, increased gain is driven by increased nutrient intake, either liquid or a calf starter. The easiest and fastest way to do this is by feeding additional liquid. We can do this by feeding a greater volume of milk, as we see in the photo, or increased solids content, or both. This slide shows us a quick review of studies that have reported the effects of pre-weaning nutrition on future milk production. Of course, not all studies indicate an effect of nutrition on future milk production, but the studies in blue are really interesting and indicate that pre-weaning growth is a better metric for predicting the effect of pre-weaning nutrition on future milk production. Feeding more milk can increase pre-weaning growth, but it can also have a negative effect on post-weaning growth. Dr. Wenping Hu published a meta-analysis from the Provimi Research Facility in New Paris, Ohio in the U.S. His team reviewed 26 treatments with 491 calves fed a moderate or high volumes of milk prior to weaning. Moderate calves were fed about 680 grams of milk replacer powder per day to weaning at 42 or 49 days. The dry matter of the milk replacer was usually about 15%. High calves were fed up to 1.1 kilo of milk replacer powder per day, again to weaning at 42 or 49 days. The dry matter was also about 15%. We found that, as expected, calves fed more milk solids prior to weaning grew faster, but they grew slower after weaning, so that by 4 months of age, the difference between the groups was quite small, as you can see here in the graph. This is because increased milk feeding reduces calf starter intake. When calves don't eat enough starter prior to weaning, the lack of rumen development results in lower nutrient digestion post-weaning and lower growth. As we think about feeding more liquid to calves, we have several options: feeding more volume, feeding more solids, or both. Let's start by considering what's normal for the calf, that is, cow's milk. Cow's milk is normally about 12.5% solids and consistently about 280 milliosmoles per kilogram. This amount of protein and fat are affected by management, diet, and environment, but the lactose concentration varies to maintain this constant osmolality or osmotic pressure. When we look at the nutrients in milk on a dry matter basis, we see that milk is about 30% fat, 26% protein, and about 6% ash, and 45% lactose. Note that we usually calculate lactose by difference. This isn't entirely correct, as other components such as oligosaccharides are found in milk. However, we generally ignore these errors. When we think about feeding calves, the variation in nutrient content of milk is important. Generally, we don't find huge variation in composition of milk from the bulk tank, as we see here in a study conducted a few years ago. However, waste milk may be a different issue. This study by Dale Moore in 2009 evaluated solids content in 14 different samples of waste milk collected from calf ranches in California that used this milk to feed to their calves. We can see that most milk was less than 12.5% solids, and 3 samples were about 10% or less in solids content. Clearly, the issues was with contamination of the milk with water. The bottom line, though, is that while milk itself may be fairly consistent in composition, the resulting product fed to calves may be quite variable. It's possible to use the Brix refractometer to monitor milk composition. The equations for monitoring whole milk and milk replacer are a little different and are shown here. Be sure when using the refractometer that you should calibrate it with distilled water every day or every time you use the instrument. It's very important. Okay, so let's take a look at feeding more milk, more volume, more solids, or both. Here's a schematic of what I mean. Let's start by feeding 4 liters of regular milk at 12.5% solids. This provides the calf with 500 grams of solids per day. Next, we'll increase the volume to 6 liters, but keep the concentration the same. Now, this calf gets 750 grams of solids, additional nutrients. Next, we'll feed the same 750 grams of solids, but do so by increasing the concentration to 15% and reducing the volume to 5 liters. If we increase the concentration to 15% but keep the volume the same, we end up providing 900 grams of solids to the calf. And finally, we can increase both the concentration and the volume and really provide a lot of nutrition to the calf. So, which of these options makes the most sense? That's what we'll look at next. A critical concept to understand as we think about more nutrition to the calf is the concept of osmolality. Osmolality is the measurement of the osmotically active molecules in a solution. Some molecules like lactose, minerals, glucose, and urea contribute to osmolality in a solution. We can see that blood has an osmolality of about 280 milliosmoles per kilogram. This concentration is called isoosmotic or isotonic. Milk has a slightly higher osmolality, about 290 to 300. Colostrum is more variable, mainly because it can vary tremendously in composition and in solids concentration. As we look at products we feed to calves, we see that CMR can vary from about 300 milliosmoles to more than 450, or even higher, depending on how much they're reconstituted. Adding oral rehydration solutions or electrolytes to water or milk really increases the osmolality. The super high osmolality of milk plus ORS is a big reason why we don't recommend mixing the two. In our first mix of CMR, we reconstitute the powder to 125 grams per liter, and we see that the number of active molecules in this mixture results in an osmolality of 320 milliosmoles per kilogram. When we increase the concentration to 150 grams per liter, the same powder is now 580 milliosmoles, much higher than the 280 of blood. This is termed hyperosmotic or hypertonic. Measuring osmolality is usually done with an osmometer, which is a laboratory device which measures the freezing point of a liquid. Freezing point is highly related to the number of osmotically active molecules in a liquid, so it can be used to measure osmolality. Lab osmometers are expensive, but most DHI labs that measure milk composition also measure the change in freezing point. This is used to determine if water has been added to milk, which reduces the osmolality of the milk. We use the laboratory in the US to measure osmolality of 4 milk replacer solutions. You see the compositions here. We reconstituted each CMR to 13, 15, 17, or 19% solids and determined the bricks, solids, and then sent samples to the DHI lab for measurement of osmolality and DHI nutrients. Now, to some of these samples, we also added salt to artificially increase the osmolality. Here is what we found. As the solids content increased, we see that the osmolality increased from 383 to more than 600 milliosmoles per kilogram, which is hypertonic. You see in the graph that there appear to be consistent changes with increasing solids. This is true and were related to the type of CMR that was used. We also conducted a regression analysis to determine what was contributing to the change in osmolality. We found that ash, urea, lactose, and the added sodium were all important. Note that the total solids content was included in all of these measurements. For example, at 13% solids, the lactose concentration might be 5%, and at 15% solids, the lactose was 6%, and so on. This analysis indicates that minerals, we measured as ash, lactose, and milk urea nitrogen were all important to the measurement of osmolality in milk replacer. Very similar results were reported by the group at Washington State University. They measured solids and osmolality from 5 different milk replacers and found a very similar change in osmolality with increasing solids. Okay, so measuring osmolality directly can be done in the lab, but more difficult to do on the farm. So, some researchers have used a calculation to estimate osmolality. Basically, you calculate the number of moles of osmotically active substances in the milk or milk replacer, including lactose and the main minerals, calcium, phosphorus, potassium, sodium, chloride, and magnesium. We don't consider the microminerals or urea in this analysis. The total number of moles are multiplied by the solids content to get the osmolality. You can see that in this calculation, the lactose is the primary contributor to osmolality, followed by phosphorus and potassium. However, in some CMR formulas, the amount of sodium might be much higher, and it can contribute significantly to osmolality. Now, we've been talking a lot about osmolality. Why? Well, the body of the calf works best at isotonic solutions, around 300. When we feed a calf a hypertonic solution, the liquid will stay in the abomasum until enough water enters the abomasum to dilute the liquid to about 300 milliosmoles. This delay in abomasal outflow can cause acidosis, resulting in abscesses, or the growth of bacteria such as Clostridium perfringens, which causes abomasal bloat and acute death. These are bad things, and we should try to avoid them when possible. Note that it's really important that calves have access to water. If they can drink water freely, then the risk of problems is much lower. When calves don't have water to drink, this can make the process much slower and really affect abomasal health. Researchers at Purdue University in the US fed calves whole milk without or with the addition of electrolytes that increased the osmolality from 292 to more than 500 milliosmoles per kilogram of solution. They measured the rate of abomasal emptying and found that the time that outflow, measured by this statistic called Tmax, was increased when the ORS was added to the milk. This reiterates the negative potential of these hypertonic solutions. The last point I'll make about osmolality is that we can influence it not only by increasing solids or with the addition of electrolytes, but also by the ingredients we use in the formula. Wilms and co-workers in the Netherlands replaced lactose with either glucose or galactose to increase the osmolality of the milk replacers. We see that lactose is a much bigger molecule, so essentially glucose and galactose are twice as osmotically active as the same mass or weight as glucose. They made 5 milk replacers containing 40% lactose as the control and increasing the amount of dextrose, and then a mix of dextrose plus galactose. These milk replacers were reconstituted to about 15% solids and fed to calves from 3 to 7 weeks of age. They calculated the osmolalities, which you see here, and then calculated the amount of markers, in this case the molecule lactulose, that appeared in the urine. The lactulose was fed to the calves, and when it ends up in the urine, it's an indication of intestinal damage. You can see here that at both 3 and 7 weeks, but especially at 7 weeks, that the higher osmolality CMR increased this indicator of intestinal damage. Okay, I've talked a lot about osmolality, but when we consider feeding more milk or especially more solids to calves, it's a concept that's so important. We must understand this concept very clearly. Remember, excess osmolality can reduce abomasal outflow and predispose calves to bloat or intestinal damage. This is particularly true when osmolality gets above 600 milliosmoles per kilo. Remember that whole milk is about 300 milliosmoles per kilogram and about 12.5% solids. I think it's best to ensure that calculated osmolality is less than 450 to be safe. You can calculate osmolality using lactose and the mineral concentrations, but remember these are just estimates and there can be considerable error in these calculations. Plus, you'll need the info on the mineral content of the CMR from the manufacturer. Let's look now at what happens when we change the solids concentration without affecting the number of grams of solids fed. In this study, we fed 48 calves milk replacer at 4 different solids concentrations, 10, 12.5, 15, and 17.5% solids. You see the osmolalities here. Now, we fed the same number of grams of solids to each calf, 625 grams per day to day 39, and then 313 grams per day to weaning on day 42. That means that we fed less volume as we increased the solids, as you see here. There were very few changes in animal performance, no effect on intake or body weight gain, etc. The only real effects were in the number of abnormal fecal days and the number of days treated, which declined with increasing solids content. When you see the change in medical days over time, we see that the calves on the 17.5% treatment were very healthy, whereas other calves had more medical days. However, this is only one study, and we're hesitant to claim that this is a consistent response. We do feel confident, however, in saying that changing solids content from 10% to 17.5% had little effect on animal performance. When most people want to change the solids concentration, they want to do so in order to increase the amount of nutrition the calf gets. In this case, we may increase the solids concentration but keep the volume the same. Let's see what happens. Researchers in Brazil fed Holstein Jeer cross calves milk replacer at 4 solids concentrations and amounts of solids per day. You can see the solids concentrations, osmolalities, and kilos fed to the calves. They measured animal performance and digestibility. Here we can see that there were some slight trends for an increase in digestibility, but these trends really were not significant. Total tract transit time was also unaffected by the solids content, suggesting that abomasal emptying wasn't dramatically affected by these formulas. They reported increased total dry matter intake, mainly from more intake of milk. Starter intake was depressed with increasing solids content of the milk. Average daily gain was improved, but body measurements and measures of mammary development weren't really affected by the feeding regime, although heart girth tended to be higher in calves fed more solids. So the bottom line here is that we can affect growth up to weaning time at 55 days of age by increasing the amount of solids fed to the calves. Let's take a look at a second trial evaluating higher solids in whole milk. Here, researchers in Iran fed calves 2 milk volumes, low and high, and 2 solids concentrations, either 12 or 17%. The low amount of milk was 5 liters per day to day 76, and then 3 liters per day to weaning at day 83. Calves fed the high treatment received 5 liters up to 8 liters per day from days 24 to 69, and then down to weaning at day 83. The effects of L versus H are in this column, and the effect of the 17 versus 12 are in this column. Generally, increasing the amount of milk had little effect, mainly because calves fed the L diets ate more starter to make up the difference in nutrient intake. However, when calves were fed more solids, especially H17, growth was increased. However, fecal score and use of electrolytes were increased also. Now let's take a look at a second study from Iran evaluating greater solids in whole milk. In this study, Norouzi and co-workers fed an increasing amount of whole milk to calves at 12.3% solids, or added skim milk powder or a milk replacer powder to increase the solids to about 18%. Unfortunately, the authors didn't report the osmolality of their mixtures. Calves fed more solids had lower starter intake, greater body weight gain, and better efficiency prior to weaning, which we see here as the time by treatment interactions. We can see that the calves were weaned at 56 days of age, and pre-weaning body weights were improved. However, body weight at 90 days were similar. Also, body measurements at 90 days were not affected by the treatments. Like that previous research we saw from WHO, calves fed higher amounts of solids may lose their advantage if the post-weaning program is not managed properly. The authors also reported that adding skim milk increased diarrhea, and they attributed this to an increase in the lactose concentration of the mixture. The final trial will look at increased solids in milk by adding milk balancers to waste milk. This study was published in JDS by Glosson et al., where calves were fed controls of 450 grams of milk per day to 56 days, that's M, or increasing amounts to 680 grams per day, that's IM, without or with added balancer at 230 grams per 450 grams of dry matter from the milk. Osmolality increased from 280 to about 480 with the addition of the balancer product. We can see that adding extra nutrients improved growth pre-weaning and also reduced starter intake. These calves were not followed post-weaning, so we don't know what happened after weaning. What kind of pre-weaning growth might we expect when we feed more solids to pre-weaned calves? Most studies that I've shown you report a gain to feed ratio of between 0.5 to 0.7 prior to weaning. That is, for every kilogram of dry matter intake a calf consumes, we can expect 500 to 700 grams of additional body weight gain per day. So let's say we're feeding 750 grams of solids per day in 5 liters of liquid, or 15% solids. Using a standard balancer product added to whole milk, I estimate the osmolality of this mix to be 480 milliosmoles per kilo. That's right on the edge of what is acceptable. If we increase the solids concentration to 1 kilo per day, but leave the volume at 5 liters, I estimate the osmolality will increase to more than 650. This is a problem. The better approach in this scenario is to increase the volume to 6.7 liters, which gives the calf the 1 kilo of solids per day, but keeps the osmolality within reasonable limits. Using our efficiency value, we can estimate that this will increase body weight gain by 150 grams per day. So let's put this all together, and I'll summarize what we know about increasing solids to calves. Okay, to summarize, we know that waste milk can vary, so it's a good idea to monitor waste milk composition frequently using a Brix refractometer. Now, we can increase the amount of nutrition we give a calf via the milk by increasing the volume fed, the solids content, or both. When we increase the solids concentration, we need to be careful about osmolality. As we saw, the osmolality of milk is about 300, which is close to that of the calf's blood. However, CMR can vary and will always increase as we increase the solids concentration. It's a good idea to measure it using a DHI lab from time to time, or to estimate it based on the nutrients in the products. Try to keep the osmolality of about 450 milliosmoles per kilogram or less. And be sure that the calves have access to water at all times. This will help reduce the risk of problems. When we increase solids content fed to the calf in any manner, we will increase growth pre-weaning. That's very clear and very consistent from all the research. If we can maintain our osmolality at acceptable levels, we shouldn't expect problems from diarrhea or other health problems. However, it's important to manage the weaning period and post-weaning nutrition to maintain the increased growth you've achieved with your more intensive liquid feeding program. So if you're interested in increasing growth, feeding milk plus a balancer is a great way to improve calf growth. Also, increasing milk solids content if you're using only milk replacer will accomplish the same goal of increasing pre-weaning growth and possibly future milk production. I want to thank you all for your attention, and I hope you found today's presentation to be valuable. I'd also like to invite you to visit calfnotes.com, a website that I run that contains lots of information about raising calves. Please stop by, and thank you again.